Hi everyone, this is Jacob Trutenic, and today I'll be presenting some information and contemporary research on chronic traumatic encephalopathy as the honorization component of my neuroanatomy course this semester. So let's get started. First things first, what even is chronic traumatic encephalopathy? Well, chronic traumatic encephalopathy, or otherwise known as simply CTE, is a neurodegenerative disease caused by repeated head injuries. The disease is classified as a tauopathy, meaning that the disease results from the aggregation of tau protein into neurofibrillary tangles, or NFTs. Normally, tau protein is responsible for the stability of neuronal microtubules. However, during trauma, the proteins can be altered through phosphorylation that ultimately cause them to accumulate into dangerous NFTs and can ultimately create plaques through these NFTs combining together. So this process is visualized in figure 1 here to the right, where we can see a normal microtubule unfolding and becoming tangled due to the phosphorylation compromising the stability of the tau protein that's holding the structure together. So, when the tau protein forms these plaques within brain cells, it can result in a loss of function and a major loss of brain material over time. And you can see in figure 2 to the right here that the disease can cause major damage throughout the brain um, over a long period of time. And it's often been compared to Alzheimer's in terms of, the amount of damage that it can do, as well as the involvement of plaques as a result of tau in the development of the disease. However, it is an entirely separate kind of tauopathy. As for how these tau proteins are induced into the brain, the exact amount of trauma required for the phosphorylation of the tau protein to occur is currently unknown, and definitive diagnosis of the condition can only occur upon autopsy after death. This means that there is currently no way to successfully diagnose CTE within living individuals, which I find to be absolutely terrifying. That's a pretty scary thing to not know if you have a disease or not. Anyways, so what does CTE cause and who's at risk of developing this disease? Well, most cases have occurred in athletes, specifically athletes from sports that involve repetitive brain trauma, or RBT, over an extended period of time. Other cases have included military personnel, victims of domestic abuse, etc., mainly just cases that involve plenty of direct head trauma. CTE results when the NFTs and the resulting plaques that I mentioned earlier induce a reduction in brain weight associated with atrophy of the frontal and temporal cortices, as well as the enlargement of the third and fourth ventricles and cerebral aqueduct. So we can see all of these areas within figure 3 and 4 to the right here, with figure 3 showing the frontal and temporal lobes, and figure 4 showing the ventricles and cerebral aqueduct locations. So when this disease is induced, these areas are critically damaged and can cause numerous symptoms. Some of these symptoms include confusion and headaches in early cases, memory loss and impulsive behavior in further developed cases, and dementia, movement disorders, tremors, vertigo, deafness, depression, and even increased suicidality in critical cases. So, how can we prevent or even treat this disease? Well, as I mentioned, a diagnosis of CTE cannot be made in living individuals, primarily due to the need of collecting samples from too many critical areas of the brain, meaning it is difficult to know if you have CTE and therefore need treatment. Some preventative methods that have been devised over the years have included upgrading helmets and mouth guards, primarily due to their benefits in preventing direct head trauma. However, it is currently suggested that the only way to avoid CTE is to avoid repetitive brain trauma altogether, meaning you don't play sports, or when you do, you're careful to ensure excessive trauma is not induced. Currently, treatments for CTE are given to those who exhibit severe symptoms believed to be associated with the disease and often revolve around treating just these symptoms rather than actually curing or diminishing the disease itself. Pretty scary stuff. Before we delve into the research I selected on CTE here, I thought it'd be a good idea to share just some fast facts about CTE, just a little bit more understanding about where it comes from, how we got to this point. The first one would be that the rates currently of the disease have been found to be about 30% among those with a history of multiple head injuries, regardless of how those injuries were caused. This shows that brain trauma of any and all kinds can cause CTE, meaning that all it takes is one strong blow that can induce the tau protein to phosphorylate and thus cause the disease to begin developing. Next would be that a man named Dr. Bennett Omalu discovered CTE in 2005 while in Pittsburgh when he was part of the coroner's office there. You can see his picture to the right here. Anyways, there's this film called Concussion that stars Will Smith as Dr. Molly, and the film details his efforts to publish the first research on CTE titled Chronic Traumatic Encephalopathy in a National League football player, despite criticism and avoidance measures by the NFL community since the research mentioned their name in a negative light. I highly recommend the movie as it details a medical story that happened fairly close to all of us at Merciers and had huge implications on this disease, as well as how medical truth overall is given to the public. Speaking of medical truth, there have been several efforts by well-known celebrities and organizations to publicly help understand and reveal the truth about this disease, including a $1 million donation to CTE research by the NFL, noted to be having no strings attached, so you can probably imagine why after the backlash from concussion. Anyways, there were also commitments to brain donations after death by current and former NFL players such as Pro Bowlers Matt Burke and Zach Thomas, as well as professional boxers and wrestlers such as boxer Mickey Ward and wrestlers Mick Foley and Booker T, etc. Um, Finally, there was also the creation of the federally funded Chronic Effects of Neurotrauma Consortium research project by President Obama in 2013, showing that the federal government had finally publicly addressed the existence of this disease, despite the NFL's resistance and attempts to cover up the existence of this disease. Um, so, there's just some fast facts about this disease. Now, on to our research. Our research was a combined research study published by 27 authors in October of 2019 in the Annals of Neurology. The research was a study of deceased American football players and military veterans who donated their brains to the research, and it aimed to observe the amount and severity of CTE within each in correlation with the amount of football played / amount of service of the veterans, as well as the position played by each. The team hypothesized that there is a dose-response relationship between the duration of the trauma and CTE risk and severity within this population. But they also looked to examine the brains of the military personnel with a football background and take their data into consideration as well, despite only having 74 donations of this kind. So, how did they do this? Well, a sample of 266 total brains from deceased American football players from the Veteran Affairs Boston University Concussion Legacy Foundation and Framingham Heart Study brain banks were collected for evaluation of the presence and severity of CTE. The donations were given to the brain banks between 2008 and 2017 and included both high school, college, and professional football players, as well as players who left football and then participated in the military. Brains of the players below the age of 20 were removed from their analysis, primarily due to such a short age not displaying chronic trauma, so it wouldn't be chronic traumatic encephalopathy, but rather short-term trauma and those effects. So they wanted to ensure that this was looking at chronic traumatic encephalopathy. So, anyways, they found within this research that 223 of the 266 participants met neuropathological diagnostic criteria for CTE. More years of football played were determined to be associated with having CTE and with less CTE severity, and sensitivity and specificity were found to be maximized at 11 years of traumatic brain experiences, so meaning playing football in this case, or military service for that matter. Anyways, figure 6 here summarizes all these results in players in terms of CTE status, which is shown in the violin plot in A here. CTE severity within positive CTE cases, which is shown in the violin plot in D. And evidence used to diagnose CTE in both microscopic and CT scan analysis, which is shown in B, C, E, and F, respectively. So, these results incorporate the length of trauma and compare this length to the resulting CTE, allowing the team to determine the odds of developing CTE at any point over the course of a career, whether it be football or military, as long as it involves trauma. So we can see here in D specifically that the plot thickens around 11 years for both mild and severe, showing that the CTE development is maximized at this length of chronic trauma for both mild and severe cases. So that means that the symptoms seem to develop at this case. Severe CTE was shown to have similar rates beyond 11 years as well. In fact, it kind of increases a little bit as well. So Um, 11 years was found to be when it was maximized, meaning when it was found that the CTE is developing at this point. Anyways, overall, these results show that a majority of those who played football or had military experience showed some form of CTE, whether it was mild or severe. Continuing on here, here we see a nice table displaying a comparison between the positions of the players and the presence and or severity of the CTE within each position in football. So we can see here that the most affected groups are the players who face the most direct head trauma, as you can probably imagine. So these included offensive linemen with 48 positive CTE cases and running backs with 37 positive CTE cases, as well as all of the defensive backs players for that matter, including defensive linemen with 46 positive cases, linebackers with 28 positive cases, and defensive backs with 30 positive cases. Of all of these cases, we also saw, well, the research team saw, a majority of them were severe. In fact, every group besides the wide receivers and the kickers or punters were shown to have more severe cases than mild cases. And the most protected groups, therefore, from advanced CTE were the wide receivers and the kickers/punters. We can also observe here that some of the veterans, who again um, the veterans, showed a tendency to develop more severe CTE as well, with 43 severe cases in veterans that left football to go and have a military career. Overall, this portion of the data shows that unless you are a wide receiver or a kicker with no military experience after you're playing football, your chances of developing CTE over time are increased heavily. So, in conclusion here, overall the research concluded that the odds of CTE double every 2.6 years of football played after accounting for brain bank selection and the magnitude of the relationship between years played and CTE status. It remained consistent. A simulation demonstrated that years played remained adversely associated with CTE status when years played and CTE status were both related to brain bank selection across widely ranging scenarios. And overall, CTE can be regarded as a serious risk within sports overall, and specifically football and military backgrounds. Feature any sport, for that matter, though, that features repetitive brain trauma, and therefore we should be focusing on prevention and treatment within these populations specifically and within our overall society. So, that being said, here are my references, and a huge thank you for listening in on my presentation here about CTE. If you have any questions about anything I mentioned today, please feel free to reach out however you feel that you can. And thanks again. Stay safe out there, everybody.